Okay, now we will talk about the row operation method to find the determinant of the matrix. Here are the steps. So first of all, we will choose row or column with most zeros. So if you are given a determinant, a matrix whose determinant is to be found, you will choose a row or column with the most number of zeros. Then for non-zero columns in that row, you will create zeros using row or the column operations. What does that mean? Once you have chosen a row or the column, in that row there are some non-zeros, some non-zero entries as well. So you will make one at one position, at any position, and for the other positions you will make everything zero. Okay, and you can use row operations or the column operations. Usually we will use the row operations because we will be dealing with rows. So the same thing can be happened with the columns as well. Okay, this is the operation which I am talking about. You can uh, add any scalar multiple of any row with any row. For example, you have any row, for example Ri. In that row you can add any scalar multiple, I mean k times any other row. This is the operation you can perform. And another operation is that you can make other entries zero except one entry of that row or the column. And this is the operation. For example, if you have something in in Rk, there is something in Rk, and you want to make, for example, this is Rk and this is Ri. For example, you have something here in Rk and you want to make here 0. How can you make 0? You can use this operation. Okay, so this operation can be used to make 0. Let's do an example. I will explain this operation later. Let's do this example, then you will understand how to perform the operation. Okay, so you have to choose a row or the column with the most number of zeros. Okay, with the most number of zeros. So I will choose a column. There are 3 columns, this one, and this one. The last 2 columns has no 0, but the first column has 1 0. So I will choose first column. Okay, in the first column, so this is the first step. First step is choose a row or the column with most zeros. So I have done the first step. I have chosen the first column. And the second step is that make zeros except one entry. There are 2 non-zero entries here. Okay, so I can take this entry as it is and I can make this 0. Similarly, I can take this entry as it is, I can make this entry to be 0. Whatever you can do, whatever is easy for you, you can do that. What I will do, I will keep this term as it is, but I will make this term 0. How can I make this 0? I can make this entry 0 by using this entry. How? If I subtract 5 times 1 from 5, this entry can be 0. Okay, so 5, so R1 minus 5 times R3. This is the operation. You can see I will perform this operation to make here 0. Okay, let's perform this operation. Here is I have performed that operation in this you can check. I have first written R1. Here is R1. 5 1 minus 1, 5 1 minus 1. This is R1. Then minus 5, you can check. Here you have minus 5, here you have minus 5, here you have minus 5. Okay, everywhere minus 5. And then R3. What is R3? R3 is 1 4 7. This is 1, this is 4, this is 7. Okay, now just calculate these values, just simplify, then you will get something. So after simplification, I got this matrix. Okay, now I can expand this determinant along the first column. So in the first column, you can check that I have to write this entry first here, and this entry is along the first row and first column. So 1 plus 1 is 2, which is even. So I will not write minus here. Then I will write something, and then I will write this entry, but this entry is along the second row and the first column. So second plus 1 means 3. 3 is odd number. So because of odd number, I will write minus here, and then I will put this 0. And then I will write this number. You can check here, but this number is in the third row and the first column. So 3 plus 1 is 4, which is even. So I will not write minus, I will write plus here as well. So now what are the terms here, here and here? So for the first space, I have this 0. This 0, I will cross this column and cross this row as well. I will end left with this determinant. So I will write this determinant in the first place. And similarly, for this 0, I will cross this and this. I will left with the determinant of again 4 entries, and that I will put here. And then I will, for the first element 1, I will cross this column and this row. Again I will left with 4 entries, and I will write the determinants. All of the determinants I will write here. Okay, so after writing these numbers and after simplification, I will end up with this result. Now let's do another example. In this example, we have to expand this determinant. So again, what we will do, we will find a row or the column in which there are more zeros. You can check that this is the column which contains most zeros. So I will expand this determinant along the third column. So once I will expand it along the third column, I will again have the determinant along this, then along this, then along this. How can I expand? Firstly, for this entry, since this entry is in the first row and the third column, so 1 plus 3 is 4. So I will not, 4 is odd even number, so I will not write minus. I will write plus here. Okay, so plus 2. So cancel this and this, you will end up with this. So this is the determinant here. You can check. And then I will write this 0. You can check. I will not write this 0 because everything times this 0 is 0, and then everything times this 0 is 0. So I will not write this. I will just calculate this. I will end up with this result. Sorry, with 30. So this is the determinant along using the row operation method. So let's do another example. In this example, we have to evaluate this determinant. So in this determinant, there is no zero, you can check. So I can choose any row or any column. So if you have to choose any row or any column, just choose a first column. So I will choose the first column. So what's the second step? In the second step, I have to choose any entry. I can choose 2 in the first column, or I can choose 3, or I can choose 1. So you could have chosen 1 to simplify things, but I can choose 2 to make you understand how it's going. So you can choose 2, then you will make this 0 and you will make this 0. So after choosing this point, how can you make this 0? And you can check that this element can become 0 if I subtract 3 minus something times 2. What is this something? So you can check if I put here 3 by 2, then this 2 and this 2 will be cancelled, then 3 minus 3 will be 0. So this something is important. That means this goes to R2, this goes to R1. So that means R2 minus 3 by 2 R1. So this operation I should perform to make this element 0. So R2 minus 3 times R1, this is the operation I will perform in R2. So if I perform this operation in R2, I will make changes in R2 in this way. You can check, because this is R2, you can check R2 is 3, 2, minus 1. This is 3, this is 2, this is minus 1. And minus 3 by 2, you can check this is everywhere, here, here and here. So minus 3 by 2 is everywhere. And R1 is 2, 4, 1. You can check this is 2, this is 4, this is 1. So this is everywhere. So if you simplify these calculations, you will end up with this result. But this is not the final result, because I have picked up this element and I have made this element 0. Now I have to make this element 0 to simplify more calculations. How can I make this element 0? You can check if I put here 1 minus something times 2. What is this something? So you can check that this something should be 1 by 2, because this 2 and this 2 will be cancelled and 1 minus 1 will be cancelled. It will end up with 0. So this is the operation. This entry will be corresponding to R3, and this entry will correspond to R1, and this is the factor. So I will perform R3 minus 1/2 of R1. So R3 minus 1/2 of R1, and this change will be done in R3. So I will make these changes in R3. You will end up with this result. If I simplify these calculations, I will end up with this matrix. Now I can expand along the first column. You can check in the first column there are 2 zeros and 1 non-zero entry. So what will I do? I will expand it along the first column. In the first column you have 2 here. 2 is in the first row and the first column, therefore 1 plus 1 is 2, and 2 is even number, I will not write minus. And then I will write this 0, because this 0 is in the second row and the first column, so 2 plus 1 is 3, which is odd number, so I will write minus. So I will write minus 0. So I will not write anything times 0, because 0 times anything is 0. Then I will write this entry, because this entry is in the third row and the first column. So 3 plus 1 is 4, which is even number. So I will write plus. So I will write plus 0. And what should I write here? Because when I will cancel this column and this row, I will left with this matrix, this submatrix, and I will write the determinant of this matrix. So the determinant of this matrix is this one. After simplification, I will end up with the result -5.